Welcome to Pre-Math. In this video, we have got this right triangle ACD inside a bigger triangle ACB, as you can see in this diagram, such that this segment AD is 2 times y, whereas this segment BC is y. And moreover, this angle A is 25 degrees. Whereas this angle B is represented by X. And now our task is to find the value of this angle X. And we are not supposed to be using calculators at all. Please don't forget to give a thumbs up and subscribe. Please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. Before we proceed any further, let me go over the basic review. Let's recall the exterior angle theorem. According to this theorem, the exterior angle of a triangle is equal to the sum of two opposite interiors, as you can see in this diagram. And here we can see this is our exterior angle, and that is going to be equal to the sum of these two opposite interior angles A and B, such that this angle C equal to A plus B. And now let me give you an example. This angle is going to be our exterior angle, and that is going to be equal to the sum of these two opposite interior angle. So this exterior angle is going to be 50 plus 60 is going to give us 110 degrees. And here's our next concept. Let's consider this triangle ABC, whose vertices are A, B, and C. And this vertex A has angle alpha, B has angle beta, and C has angle gamma. And the side opposite to this vertex A is lowercase a. Opposite to this vertex B is this side lowercase b. And finally, opposite to this vertex C, our side is lowercase c. And now let's recall the law of sines. This side A divided by sine of angle alpha is going to be equal to side B divided by sine of beta. And likewise, A divided by sine of alpha equal to C over sine of gamma. And finally, B over sine beta equal to C over sine of gamma as well. And here's our next step. Let's focus on this right triangle ACD. And now let's recall the exterior angle theorem once again. According to this theorem, exterior angle of a triangle is equal to the sum of two opposite interior angles, as you can see in this given diagram. And here in our case, we can see that this angle BDC is our exterior angle, and that is going to be equal to the sum of these two opposite interior angles. This angle is 25 degrees and this angle is 90 degrees. So therefore, this exterior angle is going to be 90 plus 25 is going to give us 115 degrees. And here's our next step. Let's assume that this side length CD is lowercase m. And now let's recall the law of sines once again. We are going to apply it on this triangle ACD. Therefore, we can write this side length 2y divided by sine of this angle 90 degrees is going to be equal to this side m divided by this sine of 25 degrees. So therefore, let me go ahead and write down 2y divided by sine of 90 degrees is equal to m divided by sine of 25 degrees. And now we know that sine of 90 degrees is 1. So therefore, in the denominator, sine of 90 degrees, I'm going to substitute this one by 1. As you can see in this next step, I have replaced this sine of 90 degrees by 1 at the denominator. And now let's go ahead and cross multiply. So therefore, we can write m equals to 2y times sine of 25 degrees. And now let's go ahead and divide both sides by y. This y and y is gone. So therefore, we are ended up with m divided by y turns out to be 2 times sine of 25 degrees. Let me go ahead and call this our equation number 1. And now let's focus on this another triangle BCD. And we are going to apply the law of sines on this triangle as well. So therefore we can write m divided by sine of x equals to y divided by sine of 115 degrees. So therefore I can write m divided by sine of x equals to y divided by sine of 115 degrees. And now let's go ahead and cross multiply. So therefore I can write m times sine of 115 degrees equal to y times sine of x. And now let's go ahead and divide both sides by y times sine of 115 degrees. And we can see on the left hand side these are gone, and the right hand side y cancel each other out. So therefore we are ended up with m divided by y equal to sine of x divided by sine of 115 degrees. Let me call this our equation number 2. And here we are ended up with these equations 1 and 2. And now let's go ahead and compare these two equations. We can see the left hand sides are same, they are identical. So therefore we can equate the right hand sides as well. So therefore I can write sine of x divided by sine of 115 degrees is going to be equal to 2 times sine of 25 degrees. And now let me go ahead and multiply both sides by sine of 115 degrees to remove this fraction on the left hand side. And here we can see this sine of 115, they cancel each other out. So therefore we are ended up with the sine of x equal to 2 times sine of 25 degrees times sine of 115 degrees. Let me go ahead and call this our equation number 3. And now our task is to find the value of sine of 115 degrees. And now let's recall the angle sum identity. Sine of alpha plus beta is equal to sine of alpha times cosine of beta plus sine of beta times cosine of alpha. And since we are looking for the value of sine of 115 degrees, so let me label this alpha as 25 degrees and this beta as 90 degrees. If we add them, that is going to be equal to 115 degrees indeed. Then the right hand side could also be written as sine of 25 degrees times cosine of 90 degrees plus sine of 90 degrees times cosine of 25 degrees, as you can see in this next step. And now let's recall the basic trigonometric ratios. We know that sine of 90 degrees is 1 and cosine 90 degrees is 0. So therefore of this cosine of 90 degrees is going to be 0 and this sine of 90 degrees is going to be 1. As you can see in this next step, 0 times sine of 25 degrees is going to give us 0 over here, and sine of 90 degrees is 1 times cosine of 25 degrees is going to give us cosine of 25 degrees. So therefore sine of 115 degrees turns out to be cosine of 25 degrees. And now let's focus once again on this equation 3. And here I have copied down this equation 3. And now we know that the sine of 115 degrees is cosine of 25 degrees. So therefore I'm going to replace this one by cosine of 25 degrees. So therefore this equation is going to become sine of x equal to 2 sine of 25 degrees times cosine of 25 degrees. And now let's recall our this angle sum identity once again. Now let's assume that alpha equals to 25 degrees and beta is 25 degrees as well. Then on the right hand side all these angles are going to be 25 degrees as well, as you can see in this next step. And now on the right hand side we can see that these two terms are identical, so we can combine them. And on the left hand side 25 degrees plus 25 degrees is going to give us 50 degrees. So therefore we are ended up with sine of 50 degrees equal to 2 times sine of 25 degrees times cosine of 25 degrees as well. And here's our final step. Let's go ahead and compare these two equations. We can see the right hand sides are identical, so therefore we can equate the left hand sides as well. So therefore I can write sine of x equal to sine of 50 degrees. And now let's recall this crucial factor. Sine of alpha equal to sine of beta means alpha equals to beta angle. So therefore our angle x is going to be equal to 50 degrees. So I can write angle x turns out to be 50 degrees. So thus our angle x turns out to be 50 degrees. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.